Hi, this is Ms. Claywell. We're going to be jumping into 4.2 solving quadratic equations today. Um, so if you could follow along with your notes. So we know two ways to solve a quadratic equation. Up to this point, we have done it with factoring. So this was unit 3 for us. However, factoring doesn't always work. So you know how there are times where we tried to do like the ACB tree, but the factor, we couldn't find anything that multiplied to A times C but add to B. So when factoring doesn't work, we have the quadratic formula. That's section 4.2. This always works. So let's go ahead and start with factoring. So we're gonna set one side equal to 0. I see that I need to do an ACB tree. A times C multiplies to 3. But adds to a B of -4. -3 and -1, so now I'm just working on factoring. There's a mistake in your notes. There should also be an X there. Actually, the mistake is in there we go. So I can pull out an X. I get an X minus 1. I can pull out a -3. I get an X minus 1 as well. So now I have X minus 3, X minus 1, and I can set each of those factors equal to 0. So this is what factoring can look like. So set each factor equal to 0. Same concept over here. Isolate y and set y equal to 0. This looks like difference of squares. So I get a positive and -4/3. So if we think about it though, factoring does not always work. So for example, my A is a 2, my B is a 7, and my C is a 5. A times C is -10, but adds to a B of 7. Yeah, there's nothing that we could think of. So when things can't factor, that's when we would use the quadratic formula. So the quadratic formula always works. And it looks like x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we get the a, b, and c from standard form. Once we solve this, we can get rational, irrational, or complex numbers. So rational numbers are ratios of integers. So like a 3/4, a 7, a -1. Irrational, it contains roots that can't simplify. So like 3 plus or minus the square root of 10. These ones are the x-intercepts on a graph. Complex contains imaginary numbers. So we learned about imaginary numbers and complex numbers last class. So sometimes when we do the quadratic formula, we will have those. The steps to doing this is to make one side equal to 0 first. So in this equation, x equals -6. So my a was a 1, my b was a -16, my c is a -39. So now I'm going to do x equals -b plus or minus the square root minus 4ac all over 2a. So she just kept plugging it into the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And then as we simplify this, I would practice entering these in your calculator. Square root of 412 is the same as 4 times 103, or 103. So because all three of these have a 2, I can simplify it by 2. So I get 8 plus or minus 2 square root 103. Oh, this 2 will go away. So my final answer is 8 plus square root 103, 8 minus square root 103. That's what that plus and minus means. One time we're going to do with a plus, one time we're going to do with a minus. These are both irrational. We're going to jump to example 3. One side's equal to 0, but I'm going to factor out an x. And then I can identify my a, b, and c. So I can say each of those equal to 0, x equals 0, and then x squared minus 2x plus 4 equals 0. And I can do the quadratic formula from there. X equals negative b, so once again, my a, b, and c. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Square root of negative 12, that'd become a negative 1, a 4, and a 3, or 2i square root 3. If you learn to break it down differently, that's okay. Once I get to this point, I see all three of these had a 2. So I can simplify that to 1 plus or minus I square root 3 over 1. Oh, I don't know what I did, you guys. So my solution types would be x equals 0, and that'd be rational, and x equals 1 plus I square root 3, and x equals 1 minus I square root 3. And both of those would be complex. Okay, this one we have an object that is on top of a 200-foot skyscrapers and falls down. It wants to know when the object will hit the ground. So we want my height to equal 0. Here's my A, B, and C. You can factor this out if you want to. You can factor out probably like at least a 4, if not, yeah. So you can factor it if you want to, or you can just jump into x equals negative b plus or minus the square root of b squared minus 4 ac all over 2a. As I simplify this, I'm going to see that I have this plus and minus. So I'm going to do it one time with a plus, and I'm going to do it one time with a minus, and I'm going to see that it does not make sense for me to use my negative time one. So my answer would be at 5 seconds, the object hits the ground. I was going to say the ball. Okay, I only have 50 seconds to get this problem done. So a football is kicked, and you want to see if it hits the receiver that's 6 feet away. So basically we're trying to see when f of x equals 0, or when the ball hits the ground / caught. So set this equal to 0, pause your screen, and solve for x. Then we'll compare answers. If you did the quadratic formula, that's fine. I'm going to factor this. I made my 2 factors, pulled out an x. I'm going to say each factor equal to 0. So I see that the ball will hit the ground at 0 seconds, which is when it was thrown, and then again at 48 yards, or 45 yards. So the kicker would not get there.